Hi, welcome back to Moose and Chemistry, periodic table lesson, Aufbau principle, exception rule. Everybody loves the Aufbau principle and knows it pretty well. Sometimes we call it the diagonal rule. It starts off with 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, 5f14, 6d10, 7p6, 6f14, 7d10, and finally 7f14. Not all the elements on the periodic table will follow the Aufbau principle or the diagonal rule. So what we're going to discuss in this lesson is which one of these elements don't do that. And I'll give you an example of one of those. Alright, so let's go ahead and let's look at the first element that doesn't do it. Chromium is an exception. It does not follow that principle. Copper is our next exception. So copper there. Now, let's go ahead and show you what copper does. All right. Copper is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Well, you'd think that would be correct. And because that's 2 and 2 and 6 make 10, 2 and 6 and 2 make 20, so copper is element number 29, right? You say, okay, I've got that, right? I've got 29 electrons. But you got a problem. This D subshell will hold 10 electrons, and you are only 1 electron away from filling it. So what you're going to do in this exception is you're going to take 1 off the 4s2, make that a 1, and then you're going to make this 3d10. So that configuration is actually going to look more like this. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. And this is the correct electron configuration for copper. Why do we do that? Because even though 4s is right here, 3d is actually in a lower energy level. So you've got to always fill in the lower energy levels before you fill in completely the upper energy levels. So there are exceptions out there. So what are some more exceptions? Well, let's go ahead and do this. Alright, a next exception is rubidium. And there we go. That's an exception. Molybdenum is an exception. We just pronounce it ruthenium. That's an exception. Rhodium is an exception. The next one is palladium. Palladium is different, so I'm going to color it different. I'm going to make this a different color because it's not just one exception, but it's a double exception. So we'll color that as a double exception. So then, back to these other guys right here. The next one is going to be silver. Silver is also an exception. Platinum is an exception. And gold is also an exception. Now, you think you would be done with that, but there is actually a couple more exceptions. And we have exceptions in our F shell, which are lanthanoids and actinoids. All right, so let's look at the next exception. All right. All right, so that exception, we would have La, which is an F shell exception, AC, which which is also an exception here. And then thallium or thorium, I think it's thorium, is a double exception. See that? And then Pa is also an exception. Uranium, U, is an exception. Is also an exception. Gd is also an exception. Cm is also an exception. Berkman, K, is also an exception. So guys, when you're doing your electron configuration for these different elements, you have to keep in mind that not all elements follow the Aufbau principle and the diagonal rule. So the ones that I have colored in right there, these are the ones that don't follow the diagonal rule. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly, and we'll see you back here at Moosing Chemistry!